Now, exercise 3, time of functioning of a cell. A galvanic cell is made up of two half cells connected by salt bridge containing an electrolyte, a solution of potassium chloride, K plus Cl minus. The first half cell is formed of an aluminum strip of mass M1 equal 1 gram, dipped in a beaker containing 50 ml of aluminum sulfate solution, in which the concentration of aluminum ions Al3 plus equal to 510 to the power minus 1 mole per liter. Then we have the first half cell, Al half cell, the mass of strip equal 1 gram, the concentration of Al3 plus equal 0.5 mole per liter, and the volume equal 100 milliliter. Sorry, the volume is 50 milliliter. The second half cell is Cu half cell. The second one is formed of copper strip of mass M2 equal 8.9 gram, dipped in beaker containing 50 ml of copper 2 sulfate solution, in which the concentration of CO2 plus ion also equals 0.5 mole per liter. Then M2 mass of CO strip equal 8.9 gram, concentration of CO2 plus ions equal 0.5 mole per liter, and the volume V equals 50 milliliter. We connect the two strips with an ammeter, which indicates that the direction of the electric current I in the external circuit is from the copper strip towards the aluminum strip. Given molar mass is in gram per mole for Al and Cu, and the elemental charge and Avogadro number. One, sketch and label this cell. 1. The galvanic cell is formed of two half cells. The first half cell, we have a strip, metallic strip, dipped in the solution, and the second half cell also formed of a metallic strip dipped in the solution. We connect the two solutions with the salt bridge. The level of solution in each half cell. We connect the two strips with an ammeter A. Al half cell, we put Al in this half cell or in this half cell, as you wish. If we put Al strip in this beaker, then the solution should contain the corresponding cation Al3 plus, and in this strip must be Cu strip, and the solution must contain Cu2 plus ion. The direction of electric current, the ammeter indicates the direction of electric current I from Cu strip to the Al strip. Therefore, the direction of electrons must be in the other direction from Al strip to Cu strip. I and E have opposite direction. This is the salt bridge. This is the ammeter. This is the Al half cell and Cu half cell. it remains the polarity of the cell: anode, cathode, negative pole and positive pole. In part 2, specify the polarity of the cell. Complete your schema by indicating this polarity. Part 2, as given the direction of the electric current from Cu strip to Al strip, and we know that direction of electric current from cathode to anode, then Cu is cathode and Al is anode. The direction of electric current from anode to cathode. From cathode to anode. In this cell, the direction of the electric current from Cu to Al. Therefore, Cu is the cathode, which is the positive pole, and Al is the anode, which is the negative pole. On the schema, we have Al is the anode, which is the negative pole. Cu is the cathode, which is the positive pole. 3. Write the equation of the half reaction taking place at each electrode. Deduce the equation of the overall reaction. At anode, Al is transformed to Al3 plus. It loses Al atom loses 3 electrons to become Al3 plus. It undergoes oxidation. This is the oxidation half reaction. At cathode, reduction takes place. Each Cu2 plus ion gains 2 electrons to become Cu atom. Reduction half reaction. Now, the overall, we have 3 lost electrons and 2 gained electrons. The number of exchanged electrons must be equal during a redox reaction. Then we should multiply the first half reaction by 2 and the second half reaction by 3 to have same number of exchanged electrons. Then the first half reaction becomes 2Al gives 2Al3 plus 2 times 3 equals 6 electrons. And the second half reaction becomes 3 Cu2 plus 3 times 2, 6 electron, gives 3 times Cu, 3 Cu. Now we simplify by 6 electron after arrow and 6 electron before the arrow. The overall become 2Al plus 3 Cu2 plus give 2Al3 plus 3 Cu. Overall cell reaction. 4. Explain how the charge balance electroneutrality of the solution in copper half cell is assured. In copper half cell, Cu2 plus ions are transferred to Cu. Cu2 plus ions are reduced into Cu atoms. Then concentration of Cu2 plus ions decreases, and therefore sum of positive charge decreases. To keep the charge balance, we have in the salt bridge an electrolyte, for example K plus and NO3 minus or Cl minus. The cation in the salt bridge move toward the cathodic half cell, and in the Al half cell we have formation of Alt plus ions. Al are transformed into Alt plus. Then the concentration of Alt plus increases while the concentration of SO4 2 minus remains the same. Here the concentration of SO4 2 minus also remains the same. Then the concentration of Alt plus becomes bigger than concentration of SO4 2 minus. That means the positive charge becomes bigger than negative charge. We have excess of Alt plus ion. Also, the excess of Alt plus ions move toward the cathodic half cell to keep the charge balance in the Cu half cell. Then we write to keep the charge balance, K plus cations in the salt bridge and the excess of Al3 plus ions in Al half cell move toward the Cu half cell to keep the charge balance in the solution of the half cell. Now, part 5, determine the initial number of moles for each reactant of the overall reaction. Deduce the limiting reactant. The reactants are Al and Cu2 plus. Then we should calculate N0 of Al. The given of Al is the mass, and the N0 of Cu2 plus, the given for Cu2 plus are concentration and volume. The mass of Al equal to 1 gram, and the molar mass equal 27. Then 5 N0 of Al equal mass over molar mass equal 1 over 27 equal 0.037 mole. N0 of Cu2 plus equal concentration of Cu2 plus times volume. Concentration 0.5 and volume equal 50 10 to the power 3, 50 milliliters, that means 50 10 to the power minus 3 liter, equal 0.025 mole. This is the initial number of mole of Al and Cu2 plus. Deduce the limiting reactant. We calculate the ratio for each reactant. Ratio of Al equal N0 of Al over stoichiometry of the reaction. Stoichiometry of Al is 2, while for Cu2 plus is 3. Then over 2 equal 0.037 over 2 equal 0.0185. Ratio of Cu2 plus equal N0 of CO2 plus over stoichiometry, which is 3, equal 0.025 over 3 equal 0.00836. We compare the two ratios, we find that ratio of CO2 plus less than ratio of Al. Therefore, CO2 plus is the limiting reactant. 6. The maximal time of functioning of a cell is the time needed for the disappearance of the limiting reactant. An electric current I equals 0.02 ampere flows from this cell, delivered by this cell. Determine the maximal time of functioning of this cell. That means the time needed for the disappearance of the limiting reactant, which is CO2 plus. To calculate the time, we should calculate Q. Q equal I times T. We are given I. If we find Q, we can deduce T. To calculate Q, we should have number of electrons. Q equal N times E. Then we need to calculate N. N is equal to, from number of mole of electron equal N over Na. Then to calculate N, we should calculate the number of mole of electron. Number of mole of electrons is calculated from the initial number of mole of CO2 plus according to the half reaction of CO2 plus. Then we start from the stoichiometry according to SR of Cu half cell, of the reaction at Cu half cell, of the half reaction of Cu, which is CO2 plus 2 electron, give Cu. We have number of mole of electrons exchanged over 2 equal number of mole of CO2 plus reacted. At the end of the reaction, number of mole of the limiting reactant equal initial number of mole. The number of mole of electron exchanged at end of the reaction over 2 equal N0. Therefore, number of mole of electron exchanged equal 2 initial number of mole of CO2 plus equal 2 times initial number of mole of CO2 plus equals 0.025 equals 0.05 mole. Now, the second step, we should calculate number of electrons from the number of mole of electrons. Number of mole of electrons equal number of electrons over Na. Then number of electrons equal number of mole times Na. Number of mole of electron equals 0.05 calculated in first step, and Na given equals 6 to the power 23 equal 3 times 10 to the power 22 electron. This is the number of electrons. Now, the quantity of electricity Q equal N times elemental charge. N 3 10 to the power 22 and E equal given 1.6 10 to the power minus 19. The quantity of charge equal 4.8 times 10 to the power 3 Coulomb. Finally, quantity of charge equal I times T, then T equal Q over I. Q 4.8 10 to the power 3 and I is given equal to 0.02. The answer is 2.4 times 10 to the power 5 seconds. This is the maximum time for the functioning of the cell. And this is the solution of exercise 3.